All right. Good morning, everyone, or afternoon if you're just looking at this now. But we're on Thursday of our first week of distance learning here. We're looking at another round of a review of algebra topics. This time around, we're going to take that concept of factoring trinomials that we did yesterday, and we're going to take that a little bit further. For what it's worth, in my opinion, this might prove to be the toughest of the days so far, but fear not, things will not just keep getting tougher and tougher. Just some days are easier, some days are tougher, or who knows, maybe you'll be fine with this. Okay, so we want to refresh that concept of greatest common factor. So let me just give you a quick example of that here. So let's say I had the numbers 8 and 12, and somebody asked you to name the greatest common factor of 8 and 12. That means it's the largest number that will divide into 8 without a remainder and divide into 12 without a remainder. I'm sure most of you can come up with it, but greatest common factor, some might say 2, because 2 will go into 8 and 2 will go into 12, but there's actually something bigger. So if you said 4, you would be correct. 4 is the largest number that will divide evenly into 8 and evenly into 12 there. We're going to take that a little bit further because occasionally we're going to have to deal with greatest common factors that involve variables as well. This is not meant to be anything too brand new, I hope. Depending on how far you got in algebra, hopefully you've at least seen this. But if you do have trouble with it, we will be more than happy to help you out. Okay, so let's start with slightly gentler ones. You have 3 terms here, so we gotta make sure we find a greatest common factor of all 3 of those. Only 2 of the terms have x's, and this last one doesn't, which means we don't have to do much with the variables yet. So instead, let's focus on the numbers. We need to find the greatest common factor for 4, 20, and 24. So you could start small. You could say, okay, 2 goes into both of them, but we want the greatest common factor. So what you'll find actually is the largest number that goes into 4, 20, and 24 is actually 4. 4 divided by 4 gives you something nice. 20 divided by 4 gives you something nice. And 24 divided by 4 gives you something nice. So we want to indicate the greatest common factor first. That is not your answer. It's just something to kind of get the ball rolling on this one. So what we're going to do, we've got 4 coming out to the front. That's where our GCF goes. So this 4 is our GCF. I mentioned a minute ago that GCF is something that divides all those numbers, which is what we're going to do now. 4 divided by 4 gives you 1. So you could put the 1 if you want, or you could leave it off. It's not going to make any difference. And we got our x squared in there because we haven't done anything with the variable terms yet. 20 divided by 4 gives us 5, but make sure you bring that x down with it. And then finally, 24 divided by 4 gives us 6. All right, that could be the tough part of the problem for a lot of people. There's a lot to keep track of there, but once you get that step established, a lot of students find that it gets a little easier. So what you'll notice is this trinomial inside the parentheses, that's the sort of thing we dealt with yesterday. And yesterday's stuff is going to come back into play, which means that 4 is just going to chill out front here. You don't do anything else with it, but you don't want to get rid of it either. And we're going to break this trinomial down by factoring it. So just like we did yesterday, you've got x squared, so we're going to split those up because x times x gives you x squared. And we're going to play that game where we need to figure out a pair of numbers that's going to multiply to 6, but also add up to 5. For the sake of time and for the sake of a little repetition, I might not write out all the factor pairs, but feel free to do that if it makes it easier for you to pick the right one. So the pair of numbers that multiplies to 6 and adds to 5 is going to be positive 3 and positive 2. You could have them switched around as long as they're both positive in this case here. And so as ugly as it looks, that actually is what you were going for. You were trying to break this down into all of its factors, similar to if you took, let's say, 21 and broke it down into 7 times 3. You can't break either of those numbers down any further, so that's the same sort of thing here. This big giant chain of multiplication, that is the factored broken down version of this right here. I can't help but think of it as food as well, but you know, it's kind of like you take a nice sandwich that was all put together and whatnot, and you say, okay, I want to see exactly what's in this. So you break it down into the bread, the cheese, and whatever else. There you lay all the different pieces out. Okay, great. So moving right along here, these might get a little more annoying, but that comes with the territory, doesn't it always? Okay, so because these first few are all going to be attacked similarly, where our GCF is just going to be a number, I might not have time to do all of them, but we'll try to make sure we give you some of the tougher ones. So let's say I jump down to this one right here. I will gladly give you the answer to any that I skipped once we go through the other ones here. So this time around, maybe this one won't be that bad, but we just want to see what happens when they throw that negative into the mix. We need to find a number that's going to go into 2, 28, and 98. And sometimes we get lucky and our GCF has to be really small. It ends up the only number that goes into all 3 of those is 2. And I want to just throw this out there. Your GCF might not always be this number right here, but you will see it quite a bit in the examples we do today. So we got our GCF. Bring that GCF out to the front of the problem, and here's where we're going to divide everything by that GCF to see what we have left over. 2 divided by 2 gives you 1, which you could keep there or you could toss it out. Negative 28 divided by 2 gives you negative 14. Bring the x down with it. And then 98 divided by 2 will give you 49. Okay. So we got that big step taken care of, but we're going to continue down. And here's where we're going to break this trinomial down into a binomial times a binomial. So let's play that same game again. Oops, doing things out of order. Hold on. Let's put my x's in there because x times x gives us x squared. We want to think of numbers that multiply to 49, but also add up to negative 14. Most of us, when we think 49, we're probably going to think 7 and 7, which is mostly correct. It's just that if you want those 7s to add up to a negative 14, you need both of them to be negative. And this is what we call a perfect square trinomial because it breaks down into the same 2 things twice. That'll happen once in a while, but notice your factors could also be different as well. So this big chain of multiplication, that's your factored form for number 3. Great. All righty. Again, just for the sake of time, I might have to skip examples here and there. What I really want to jump to next is I want to see what happens when there's a negative on the front there. Okay. I might be leaning more towards number 6. Again, any examples I skipped, I'll make sure we give you the answers to those at the end. So feel free to try those in the meantime if you want, and then check to see how you're doing. Okay, so this time around, same thing, we're just going to look at the numbers. So if you're thinking of it 5, 20, and 20, you'll notice that the only number that really goes into 5, 20, and 20 is 5. Here's where a little wrinkle gets added to it. That first term has a negative on it. Therefore, we want to include the negative in our GCF. And the reason for that is if we're able to factor out that negative, that's going to make our first term in our next step come out positive. If that doesn't make a whole lot of sense right now, let me take you through some more of this and we'll show you what we mean. So -5, we're going to situate that out front. And here's where factoring out a negative helps out. -5 divided by -5, that's going to give us a +1, or a +1r squared, which again, you can put the +1 or you could throw it away. If we had just used +5 as our GCF and started trying to factor things out, we would end up with a -r squared in this step, and that's a lot tougher to factor. So speaking of which, if we keep that going, -20 divided by -5, that'll give you a +4, bring down the r, and then same thing here, that's also going to divide out to 4, but no r because this didn't have it. So you'll notice when you factor out a negative, that ultimately ends up changing the signs of your other terms. I don't want you to think too much into that because you might confuse yourself. Just factor out the negative if it's on the first term, and then if you divide out, carefully paying attention to those signs, you should get the right pieces down here. Okay, if you've gotten that far comfortably, then hopefully this next step won't be too difficult here. Looks like this is going to be another situation where we get the same term showing up a few times, where if we want numbers that multiply to 4, but also add to 4, some of us can think of it pretty quickly that the only pair of numbers that does that are 2 and 2. And we didn't have any negatives inside the parentheses, so looks like we're just going to need positives. So again, sometimes you can get the same pair of, or the same number in both parentheses. It just depends on what you're looking for. But bottom line, this whole thing is your final answer. I should have mentioned this with number 3, but occasionally you might see that answer shorthanded here. So with a little bit of room I have left, here's how else you might see that answer. You've got the -5. And because you have something times itself right here, you might also see people just write it as r plus 2 or whatever to the second power. This means the same thing. You're welcome to write it like that. Occasionally, you might see a multiple choice question where the answer is shorthanded like that. But I have total faith that you guys are sharp enough to realize that they are the same thing. Okay. Moving along now to some slightly tougher ones. I know what you're thinking. You're thinking, oh my goodness, those last few were tough enough. What's going on here? Well, we will try to make it as painless as we can here. Due to time, we might not get to every single one, but we'll at least try to give you what you need. So this time around, let's start trying to look for our GCF. Let's start with the numbers again. This first number is positive, so we don't have to factor a negative out. So if we think numbers that go into 3, 3, and 90, no big surprise, you're going to see 3. Here's the little addition to it. If you look at all 3 terms in this problem, they all have some sort of X term in them. Now, I don't know if this is going to be easier for some people if I do it this way, or if it's going to be tougher. But sometimes what I like to do is I like to rewrite the original expression with those exponents expanded out. So x to the third gave me this, x squared gave me that, and this didn't have an exponent, so it stayed like that. So when you're looking for a GCF, you want to factor something out that they all have in common here. So you'll notice they all have some amount of x's. So that's what we're going to be doing in this one here. We're going to say our GCF is 3x. Now, if that blew your mind, don't worry, we're going to show you how to work with that. So if our GCF is 3x, bring that out to the front. And then we're basically going to do some division again to see what we have left. 3 divided by 3 is 1, so you can put the 1 if you want, or you can leave it. But where the tricky part comes in is students might not always feel comfortable dividing with variables. So maybe instead of thinking of it as division, it's kind of thinking of it this way. When you do 3x to the, or excuse me, 3 and then x to the third power, and you factor a 3x out, you've dealt with the 3. But it's kind of like you're taking an x off of each of those terms when you collect what's going in your parentheses. So if you took an x off of this, you've got 3 and then a pair of x's, or excuse me, I'm sorry. We already dealt with 3. You've got a pair of x's, so just x squared. See, I almost confused myself there. Sorry about that. Negative 3 divided by 3, that'll give you negative 1. So again, you can keep it in there or you can toss it out. You had x squared, but you're factoring one of them out, so you still have an x left over in there. If this is a little tricky for you, it's normal. Just stick with it and you'll pick up a little bit of it each time. Finally, negative 90 divided by 3 gives us negative 30, and we factored an x off of it, so there's no x's left on this term right here. And this is what you're trying to end up with in all these. Some sort of x squared term, or whatever the letter is, some plain old x term with whatever number on it, and then just a number term at the end. So that might kind of give you a template for what to look for. All righty, let's bring this one home. So now if you're going to factor this, you've got x and x, and we got to play that game where we need numbers that multiply to negative 30, but that add up to negative 1. It's okay if you can't come up with them as quickly as I do or as some of your peers do, but the pair of numbers that's going to do that is going to be negative 6 and positive 5. Yes, you can have the 6 and the 5 switched around as long as the 6 gets the negative and the 5 gets the positive. So this monstrosity, that is the final factored form of that original expression. Yeah, that one was a little tougher. That tends to happen when there's variables involved in your GCF. But no worries here. We will help you through as much of this as need be. Okay, just because we're running short on time, maybe we'll look at number 8, because I think that's the type you're going to see most of. At the end of the video, any examples that I skipped over, I will put up the answers for that real quick for you. Okay, so this time around, notice there's no number on the front there. You can put a 1 in front of it, but it doesn't really hurt or help you there. Maybe I will just for the heck of it. You need a number that goes into 1, 8, and 15. So you could say, okay, part of my GCF is 1, or you could just not worry about the numbers right now. But something they all do have is the letter C. So you could say your GCF is C or 1C. Let's bring that out front. And here's the tough part. Don't mind me. Let me just expand this original expression out again, because it helps me, but if it's kind of a waste of time for you, that's fine. You don't have to do it this way. So you factored out a C. If you used 1C as your GCF, you could go through and divide everything by 1, but dividing by 1 is not going to change anything. So we're really going to be focusing on the letter C. If you're factoring a C off of this first chunk, that means you've got C times C left, or C squared. We bring down the -8. If you're factoring a C off of this, you've got a single C remaining. And then finally, the 15 comes down, and you factored a C off of this one as well. So that's the idea when you factor, when your GCF has a variable in it. That tells you how many or what you're taking out of each term of that trinomial. Let's bring it on home. So if we're trying to break down this stuff in the parentheses, C squared means we need to split it into C and C. And we'll do that little trick where we need numbers that multiply to 15, but also add up to -8. Take as much time as you need to come up with these. If you need to list out the pairs, factor pairs of 15, that's fine. But I can tell you that the pair that's going to do it is going to be -3 and -5. And voila. So yeah, those are fun. We still have office hours every day, and you know, Friday we'll have a live Zoom session to see if we can review and clear up any of this. I'm going to pause the video for a moment, and then I'll work on putting up the answers to those ones. Okay, and then for anybody who wanted the answers to those ones we didn't quite have time for, there was a few from the front, so feel free to pause this as needed if you need more time to jot it in, or if you just wanted to try it and check it. So for number 2, our GCF was just 2. We factor that out and we end up with these pieces. And then to factor this, numbers that multiply to +25 and add up to -5, you would need a duplicate of -5 and -5. Or you could shorthand that the way we did number 4. Oh, we didn't do number 4. Number 6, I meant, sorry. Number 4, same sort of idea. The GCF is 3. Divide it out, you get these terms. And then to factor this, you need numbers that multiply to -12 and add up to 1. So that's where you get +4 and -3. Number 5, that's similar to number 6 in the sense that you need to factor out a negative because that first number in the problem is negative. So you factor that out, you divide, and these are the pieces you end up with. And then to bring it home, the numbers that multiply to 16 and add up to -8 will be -4 and -4. If anybody was up for it, number 9 was probably the toughest of the bunch here, because notice that your GCF ends up being y squared. That's because they all have at least 2 y's that you can give up. No numbers, though, because this didn't really have a number on it. So if you factor a y squared out, notice that each of these lose some of their y's. So this was y to the 4th, it got knocked down to y squared. This was y to the 3rd, it got knocked down to y to the 1st. This had y squared, but if you factor that out, it just has the 10 left. So that part could be really tough, but finishing it off, that should be a little bit easier. That comes down, numbers that multiply to -10 and add to -9 would be -10 and +1. I don't think you're going to run into too many like that, but you know, we will give you as much help as you need. Just reach out to us, come to our office hours, and we'll do whatever we can for you. Hopefully we'll see you guys Friday for our live Zoom session.